All right, let's dive in. Today, we're going on this really incredible journey. One you're actually taking right now and thousands of more times today without even thinking about it. We're going to follow the path of a single breath all the way from the outside world deep into your body. So let's get started. Just think about that for a second. Over 20,000 times a day. It is without a doubt one of the most basic things our bodies do to keep us alive. But this automatic process, it's actually a complete masterpiece of biological engineering. So what is really going on in there? It's so much more than just moving air in and out. Your respiratory system is this massive, intricate network that's really doing two huge jobs. First, it's all about gas exchange, getting that fresh oxygen in and swapping it for waste carbon dioxide. And second, it acts like this super sophisticated air conditioning unit. It purifies, warms, and humidifies every bit of air before it gets anywhere near your delicate lungs. Okay, so our journey starts right at the entrance, what we call the conditioning zone. This is basically boot camp for air, where it gets prepped for the long trip down into the body. And it all starts with the nose. It's pretty amazing how much your nose does besides just smelling things, which, by the way, is handled by these olfactory receptors. You've got this sticky mucus lining that acts like flypaper, trapping dust and gunk while also moistening the air. At the same time, blood vessels right under the surface are warming that air up to body temperature. And you see those weird-looking folds? Those are called conchi. Their whole job is to stir up the air, creating turbulence to make sure every last particle is cleaned, warmed, and moistened. It's a brilliant built-in filtration system. So once the air is properly conditioned, it continues its trip down through the pharynx. That's just the fancy name for your throat. Now here's the thing, this is a shared space. It's a passageway for both the air we're following and for food. That creates a little bit of an engineering problem, right? But the body has a really clever solution. And that solution is this cool little flap called the epiglottis. Think of it like a traffic cop at a busy intersection. When you're just breathing, it stays open, directing air down into your larynx or voice box and then onto the lungs. But the second you swallow, it snaps shut, covering the airway and making sure your food and drink go down the right pipe, the esophagus. It's a genius little piece of anatomy. So the air is now warmed up, filtered, and headed in the right direction. Now we enter the next phase of the journey, down the superhighway that leads straight to the lungs. And this highway is your trachea, also known as the windpipe. To make sure it never collapses and cuts off your air, it's held open by these strong, C-shaped rings of cartilage. Plus, it has its own cleaning crew. These microscopic hairs called cilia are constantly sweeping mucus filled with trapped dust and debris up and out of the lungs. Right at the bottom of the trachea, the path splits in two. It divides into these two big branches called the bronchi, one for each lung. And from there, they just keep branching out, over and over again, into millions of tinier and tinier tubes called bronchioles. It honestly looks just like a huge upside-down tree spreading out inside your chest. And if we follow these tiny branches all the way to the very end, we finally reach our destination. This is it. This is the most important stop on the entire journey, the place where the great gas exchange happens. Now, before we look at the exact spot, you have to understand the setup. The entire system is designed to get air and blood incredibly close to each other, separated only by what's called the respiratory membrane. And this barrier is, well, it's paper thin. It's almost unbelievably thin. And that's absolutely critical for allowing gases to just slip right through. And here they are, the alveoli. We're talking about millions of these little grape-like air sacs. You can see how they're totally wrapped up in this dense web of tiny blood vessels called capillaries. So the air we've been following is now sitting inside these sacs, literally just a single cell's width away from your blood. That's how close they are. So what happens next all comes down to a simple process called diffusion. See, the blood that shows up here is low on oxygen and full of carbon dioxide waste. The air in the alveoli is the complete opposite, packed with oxygen. So just naturally, the oxygen moves from where there's a lot of it, the air, into the blood. And the carbon dioxide does the reverse, moving out of the blood and into the alveoli, ready to be exhaled. It's a simple, elegant, and totally vital exchange. Okay, so we follow the path the air takes, but what's actually powering this whole thing? I mean, what makes the air move in the first place? Let's take a look at the unseen engine that drives every single breath you take. Breathing is actually all about physics. It really just comes down to changes in volume and pressure. When you want to inhale, your big diaphragm muscle contracts and pulls downward. This makes your chest cavity bigger, which lowers the pressure inside, and that causes air from the outside to rush in to fill the space. Then, exhaling is usually pretty passive. The diaphragm just relaxes, your chest cavity gets smaller, the pressure goes up, and the air gets pushed back out. Simple as that. But it's not just the diaphragm doing all the work. The muscles between your ribs, your intercostals, they also contract, pulling your whole rib cage up and out. This expands your chest in every direction, creating this powerful vacuum effect that literally pulls air deep down into your lungs.
Now, most of the time, this system runs like a well-oiled machine. But sometimes it does some pretty weird things, right? What about those involuntary gasps and pops and sudden explosions of air that we can't seem to control?
So let's break these down real quick. You get a hiccup? That's nothing more than a sudden, random spasm of that diaphragm muscle we were just talking about. A cough? That's a controlled blast of air upwards, designed to clear junk out of your lower airways, like your trachea. And a sneeze is basically the same idea, but the air is rerouted at super high speed through your nose to clear out that first conditioning zone. This whole journey is incredibly resilient, but it's not invincible. The pathway can get damaged. So what happens when this perfectly designed system starts to fail? Well, in diseases like COPD, that journey gets seriously disrupted. This often happens when irritants, like cigarette smoke, cause two major problems. One is chronic bronchitis, where you get inflammation and tons of mucus that clog up that whole bronchial tree, the highway to the lungs we talked about. The other problem is emphysema, where the actual walls of those precious alveoli get destroyed. Both of these things block the airway and dramatically reduce the space available for gas exchange, making every single breath a real struggle. And that brings us right back to where we started. This complex, elegant system just keeps on working, breath after breath, performing this incredible dance completely on its own, over 20,000 times a day. So, considering everything it does for you, day in and day out, what's the most important thing you can do to protect your next 20,000 breaths?